Hi, hello my dear students, a very good evening to all of you. Warm welcome to Turito live classes. We are discussing the chapter polynomials. In the last class we have discussed how to factorize the polynomial. In today's class also we are going to discuss factorization of polynomials by grouping the terms of the given expression. So, factorization by grouping. So, once we can recap what we have discussed in the last class. So, methods of factorization. So, if the all terms of the given polynomial contains a common term, then we can take the term as common. Next, factorization by taking out the common factor. Okay. So, we have discussed those two concepts and we have done some problems related to those concepts. Now, learning objectives means what we are going to discuss in today's class. So, we will learn the following concepts in this topic: factorization by grouping. So, sometimes all the terms of the given polynomial may not contain a common term. In these cases, we can group the terms, from that we can take the common factor. So, that is known as factorization by grouping. Next, after that we can do some problems related to that factorization by grouping. Now, factorization by grouping. In the last class we have discussed factorization of polynomials. In that class, if in the given polynomial, if all the terms have a common factor, but it is not necessary that all the terms of the given polynomial may not have common factor always. So, in this case we can regroup the terms, from that we can find we can express the given polynomial as the product of factors. Sometimes in the given polynomial it is not possible to take out a common factor directly. In this case we can group the terms of the polynomial in such a manner that we may have a common factor. If all the terms of the given polynomial do not have a common factor, then by grouping the terms, means by writing two terms at one place or by writing three terms at one place. So, we can group the terms. So, we can group the terms of the given polynomial. So, you may consider two groups or three groups according to the given problem, you may get the number of groups. After grouping the terms of the given polynomial, from that particular group we can take the common term as common. So, sometimes in the given polynomial it is not possible to take out a common factor directly. In this case we can group the terms of the polynomial in such a manner that we may have a common factor. Example, if you take this one, AB plus BC plus AX plus CX. By observing this expression, clearly we can say there is no term common. How many terms are there? 1, 2, 3, 4. 4 terms are there, but by observing these 4 terms, easily we can say there exists no term as common. So, that is why here if we take AB plus BC one term. Okay. So, by taking AB plus BC as one term. So, by taking AB plus BC one term and AX plus CX as one term means one group. So, by taking AB plus BC, from this AB plus BC clearly B is a common factor. So, that is why from this group if we take B as common, so here we have A, here we have C. So, B of A plus C. So, from AX plus CX it is clear X is a common factor. That is why by taking X as common you will get X of A plus C. Here we have A plus C, here also we have A plus C. That is why by taking A plus C as common you will get, here we have B, here we have X. So, A plus C into B plus X. Total 4 terms are there, but all the 4 terms do not have a term in common. That is why I have taken the first 2 terms as one group, AB plus BC, and by taking AX plus CX as second group. From the first group you can take B as common, from the second group you can take X as common. So, we have expressed a plus c into b plus x. 4 terms are given in the polynomial. We have expressed that polynomial as the product of 2 terms a plus c and b plus x. Next, a square plus b minus ab minus a. Here also in this example we have 4 terms, but all the 4 terms do not have a term in common. So, where the first term is a square, last term is minus a. So, let us consider those 2 terms as one group. Those 2 terms as one group. The middle 2 terms b minus ab. So, by writing a square minus a at one place, that is one group. By writing b minus ab, from this we can take minus as common. By taking minus as common, you will get minus of ab minus b. From a square minus a, you will get a as common. Why? A square can be written as a into a. So, by taking a as common, you will get a into a minus 1. Here we have b, here we have b. So, that is why by taking b as common, you will get minus b of a minus 1. Again, by taking this a minus 1 as common. So, what will you get? A of a minus 1 minus b of a minus 1. By taking a minus 1 as common, we got a minus 1 into a minus b. In the first example, we have taken first 2 terms as one group, last 2 terms as one group. In this example, I have taken first term and last term as one group, the middle 2 terms, second term and third term as second group. Okay. So, with respect to the given problem, we can group the terms. If you take a square minus ab and b minus a. So, for example, if we take first term and third term, a square minus ab. Next, if we take second term and fourth term, b minus a. So, from a square minus a, if we take a as common, you will get a of a minus b. From b minus a, if you take minus 1 as common, you will get minus of a minus b. Again, by taking this a minus b as common, we got a minus 1. So, a minus 1 into a minus b. Here also we got the same expression. So, that is why in the second example, by taking first and third term and second and fourth term as 2 groups, you will get the same answer. It is not necessary to take first and last term as one group, the middle 2 terms as one group. Alternately, you can take first and third term as one group, second and fourth term as one group. So, by simplifying again, you will get the same answer. So, hope you understood. Now, let us do the problems related to this concept. Now, so problem number 1, factorize x square plus 1 by x square plus 2 minus 2x minus 2 by x. That is the given expression, x square plus 1 by x square plus 2 minus 2x minus 2 by x. Total 5 terms are there, but all these 5 terms do not have a term in common. So, if you consider the first 3 terms as one group, so here we can write x square plus 1 by x square can be written as 1 by x whole square plus 2. 2 is there. By dividing and multiplying by x, we can write 2 into x into 1 by x. So, let us take this is one bracket. From minus 2x minus 2 by x, if we take minus 2 as common, here we can take minus 2 as common. So, the first term is x, next term is 1 by x. So, consider the first 3 terms, x square plus 1 by x square plus 2. So, x square can be written as x whole square, 1 by x square can be written as 1 by x whole square. Here 2 is there, divide and multiply by x. So, why we have done like that? Why we have divided and multiplied by x? So, by observing, if you suppose that x equal to a and 1 by x equal to b, clearly this is in the form of a square plus b square plus 2ab. So, we have the identity a plus b whole square equal to a square plus b square plus 2ab, a square plus b square plus 2ab. So, here in place of a we have x, in place of b we have 1 by x, x square a square, 1 by x square b square 2ab x into 1 by x. So, by applying this formula a plus b whole square, since in place of a we have x, in place of b we have 1 by x. So, x plus 1 by x whole square, x plus 1 by x whole square minus 2 into x plus 1 by x, where x plus 1 by x whole square means x plus 1 by x into x plus 1 by x. X plus 1 by x whole square can be written as x plus 1 by x into x plus 1 by x. So, that is why we can take x plus 1 by x as common by taking x plus 1 by x as common. So, from x plus 1 by x whole square we have taken x plus 1 by x as common. So, the remaining part is x plus 1 by x. Since we have taken x plus 1 by x as common, we will get minus 2. So, that is why we can express the given polynomial x square plus 1 by x square plus 2 minus 2x minus 2 by x as x plus 1 by x into x plus 1 by x minus 2. So, take the first 3 terms as one group, last 2 terms as one group. So, you can apply the formula a plus b whole square equal to a square plus 2ab plus b square. So, finally, we got x plus 1 by x into x plus 1 by x minus 2. So, hope you understood. Next problem. Factorize 1 plus x plus y minus z plus xy minus yz minus zx minus xyz. So, 1, 2, 3, 4, 5, 6, 7, 8 terms are there, but all these 8 terms do not have a term in common. So, that is why we have to regroup the terms. Here we have 1 plus x plus y minus z plus xy minus yz minus zx minus xyz. Here let us suppose that 1 plus x is first group, 1 plus x is first group. Next, here we have y, here we have xy. From these two terms we can take y as common. By taking y as common from y plus xy, then what will we get? Y into, here we have 1, here we have x. So, y into 1 plus x. Here we have minus z, here we have minus zx. From these two terms, if we take minus z as common, from minus z and minus zx, by taking minus z as common, we will get 1 plus x, minus z of 1 plus x. So, next here we have minus yz, here we have minus xyz, minus yz minus xyz. From these two terms we can take minus yz as common. So, you will get 1, here we have plus x. So, first two terms 1 plus x I have taken, that is one group. From y and xy I have taken y as common. So, y of 1 plus x, that is second group. From minus z and minus zx, take minus z as common, we got 1 plus x. From minus yz minus xyz, by taking minus yz as common, so you will get 1 plus x. By observing 1, 2, 3, 4 groups are there. For all these 4 groups, clearly 1 plus x is common term, 1 plus x is common term. So, that is why by taking 1 plus x as common, here we have 1, here we have y, here we have minus z, here we have minus yz, minus yz. Again in the bracket we have 1 plus y minus z minus yz. So, 1 plus x into, you can keep as it is, you can take 1 plus y as one group. From minus z minus yz, from minus z minus yz, if you take minus z as common, you will get 1 plus y. So, 1 plus y, from minus z minus yz, by taking minus z as common, 1 plus y. Again in the bracket we can take 1 plus y as common. So, 1 plus x into 1 plus y into, since we have taken 1 plus y as common, here we have 1, here we have minus z. So, that is 1 minus z. So, we have expressed the given polynomial as the product of 3 linear polynomials, 1 plus x, 1 plus y and 1 minus z. So, by multiplying these 3 terms, again you will get the given polynomial only. So, since all the terms of the given polynomial do not have a term in common, I have grouped the terms. So, 1 plus x from y minus yz by taking from y plus xy take y as common, from minus z zx take minus z as common, from minus yz minus xyz take minus yz as common. Again, by observing these terms, clearly 1 plus x is common. So, 1 plus x of 1 plus y minus z minus yz. So, from minus z minus yz we can take minus z as common. So, 1 plus x of 1 plus y minus z of 1 plus y. Again, by taking 1 plus y as common, we got 1 plus x into 1 plus y into 1 minus z. Hope you understood, ma'am. Next problem. Factorize 2x plus 3y whole square minus 8x plus 12y. Okay, ma'am. So, this is the given expression 2x minus 3y whole square minus 8x plus 12y. 2x minus 3y whole square minus 8x plus 12y. Here from minus 8x plus 12y we can take minus 4 as common. If you take minus 4 as common, this should be 2x minus 3y. So, keep the first term 2x minus 3y whole square as it is. From minus 8x plus 12y, if we take minus 4 as common, you will get 2x 3y. 8 can be written as 4 into 2, 12 can be written as 4 into 3. So, since we have taken 4 as common, minus 4 as common, we can write 2x minus 3y. First term is 2x minus 3y whole square, means 2x minus 3y into 2x minus 3y. The second term is 2x minus 3y. So, that is why from the first term and second term minus 4 of 2x minus 3y, we can take 2x minus 3y as common. By taking 2x minus 3y as common, you will get 2x minus 3y. Here we have minus 4. So, we can express the given polynomial 2x minus 3y whole square minus 8x plus 12y as the product of two polynomials like this: 2x minus 3y whole square, 2x minus 3y into 2x minus 3y minus 4. Again, by multiplying these two, you will get the given polynomial only. So, here by observing the given polynomial, we have to know, so which term is common for the terms. According to that, you can group the terms. You may get 2 groups or 3 groups or 4 groups, whatever the number of groups may be. Okay. Next, factorize x square plus y minus xy minus x. Can anyone say what is the first group, what is the second group? You can send your answers in the chat box. X square plus y minus xy minus x. If you take the first term x square, last term minus x, that is one group, and y minus xy as one group. So, here x square plus y minus xy minus x. So, if we take x square minus x as one group, x square minus x as one group, the middle two terms as one group, y minus xy. Here x square means x into x, that is why we can take x as common. So, by taking x as common, you will get x of x minus 1. Here if we take y as common, but here we have x minus 1 is there, that is why let us take minus y as common. By taking minus y as common, here we have x, here we have 1. So, x minus 1. So, by taking x as common from the first two terms, x of x minus 1, by taking minus y as common from the next two terms, minus y of x minus 1. Again, by taking this x minus 1 as common, you will get x minus 1 into x minus y, x minus 1 into x minus y. So, that is why we can express the given polynomial x square plus y minus xy minus x as the product of two polynomials like this: x minus y into x minus y. Hope you understood. Next problem. Factorize 3ax minus 6ay minus 8by plus 4bx. So, the given polynomial is 3ax minus 6ay minus 8by plus 4bx. By taking the first two terms 3ax minus 6ay as one group, if we take 3a as common, you will get x minus 2y. Here if we take minus 8by plus 4bx as one group, from that group you can take 4b as common, again you will get x minus 2y. So, from the first two terms, by taking 3a as common x, so from the 6 we have taken 3 as common. So, 2 we have taken a as common y. So, 3a of x minus 2y from minus 8by plus 4bx by taking 4b as common. So, from 4bx we have taken 4b as common x, from 8by we have taken 4b as common. 8 can be written as 4 into 2. So, minus 2y. First term is 3a of x minus 2y. Second term is 4b of x minus 2y. So, again by taking this x minus 2y as common, you will get x minus 2y into 3a plus 4b. So, by taking x minus 2y as common, we got x minus 2y into 3a plus 4b. So, we have expressed the given polynomial 3ax minus 6ay minus 8by plus 4bx as the product of two polynomials like this, x minus 2y into 3a plus 4b. So, by observing all these problems, clearly we can say all the terms of the given polynomial do not have a common term. That is why we have grouped the terms by writing first two terms, last two terms, or by writing first term, third term, second term, fourth term, like that. With respect to the given polynomial, you can group the terms. From that particular group, you can take the common factor. From the second group also, you can take the common factor. Finally, you will get the product of the factors of the given polynomial. Next, factorize x square plus 1 by x square minus 2 minus 3x plus 3 by x. So, this problem is just like the first problem. Here we have x square plus 1 by x square minus 2 minus 3x plus 3 by x. X square plus 1 by x square minus 2 minus 3x plus 3 by x. So, take the first three terms x square plus 1 by x square minus 2. By taking the first three terms as one group, where x square can be written as x whole square, 1 by x square can be written as 1 by x whole square, minus 2 is there, by dividing and multiplying by x, minus 2x into 1 by x. So, let us take this is one group. From these two terms, minus 3x plus 3 by x, we can take minus 3 as common. So, you will get x minus 1 by x. Sorry. So, by taking minus 3 as common, we got x minus 1 by x. By observing the first bracket, clearly this is in the form of a square plus b square minus 2ab. So, we have the identity a square plus b square minus 2ab equal to a minus b whole square. A square plus b square minus 2ab equal to a minus b whole square. Here in place of a we have x, in place of b we have 1 by x. So, that is why we can write a minus b, x minus 1 by x whole square minus 3 into x minus 1 by x, where x minus 1 by x whole square means x minus 1 by x into x minus 1 by x. Here we have x minus 1 by x. So, that is why we can take x minus 1 by x as common by taking x minus 1 by x as common, you will get x minus 1 by x. Here we have minus 3. So, we have expressed the first three terms as x whole square plus 1 by x whole square by dividing and multiplying by 2, minus 2 into x into 1 by x. From the last two terms minus 3x plus 3 by x, by taking minus 3 as common, we got x minus 1 by x. So, we can write these three terms as x minus 1 by x whole square according to the formula a minus b whole square equal to a square minus 2ab plus b square minus 3 into x minus 1 by x. So, here we have x minus 1 by x, here also we have x minus 1 by x. So, take x minus 1 by x as common. So, from the first term we can write x minus 1 by x, from the second term we can write 3. Hope you understood. Next problem. Factorize 2x plus 4y minus 8xy minus 1. 2x plus 4y minus 8xy minus 1. The given polynomial is 2x plus 4y minus 8xy minus 1. Here if you take the first term and last term as one group, 2x minus 1. Next, from the middle two terms 4y minus 8x, if you take minus 4 as common, then you will get 2y minus x. Here we have 2x minus 1, 2x minus 1. If you take the first term and last term as one group, 2x minus 1. From the middle two terms 4y minus 8xy, 4y minus 8xy. If you take 4y as common, so you will get 1 minus 2x. But here we have 2x minus 1. That is why we can take minus 4y as common. By taking minus 4y as common, where 8 can be written as 4 into 2. So, since we have taken 4y as common, here you will get 2x. Since from 4y we have taken minus 4y as common, you will get, that is minus 1. Here we have 2x minus 1, here we have 2x minus 1. That is why by taking 2x minus 1 as common, you will get 1 minus 4y. 2x minus 1 into 1 minus 4y, that is the product of the factors of the given polynomial 2x plus 4y minus 8xy minus 1. Here I have written the first term, last term, 2x minus 1 at one place, that is one group. By taking the middle two terms 4y minus 8xy, take minus 4y as common. So, 2x minus 1 minus 4y into 2x minus 1. From these two terms, by taking 2x minus 1 as common, we got 2x minus 1 into 1 minus 4y. Okay. Next problem. Factorize ax plus by whole square plus bx minus ay whole square. So, directly we do not have any common factor. So, that is why, but by observing the given two terms, the given polynomial contains two terms. First term is ax plus by whole square, second term is bx minus ay whole square. By expanding ax plus by whole square by using the formula a plus b whole square equal to a square plus b square plus 2ab. By expanding the second term bx minus ay whole square by using the formula a minus b whole square equal to a square plus b square minus 2ab. Ax plus by whole square plus bx minus ay whole square, bx minus ay whole square. So, where the first term is in the form of a plus b whole square. So, we have the identity a plus b whole square equal to a square plus 2ab plus b square. Similarly, by observing the second term, that is in the form of a minus b. So, by writing the identity a minus b whole square equal to a square minus 2ab plus b square. So, where in ax plus by whole square a is ax and b is by. Here a is bx and b is ay. So, a square ax whole square a square x square plus 2ab, 2 into ax into by. So, 2ab xy, 2ab xy plus by whole square, b square y square plus b square y square. Here bx minus ay whole square, that is in the form of a minus b whole square, a square plus b square minus 2ab, where a means bx, a square b square x square minus 2ab, minus 2 into bx into ay minus 2ab xy plus b square a square y square. So, from this you will get where plus 2ab xy minus 2ab xy get cancelled. So, the remaining terms are, here we have a square x square plus b square y square plus b square x square plus a square y square. So, here we can write a square x square. Here we can take a square x square plus b square x square. So, by writing these two terms at one place, a square x square plus b square x square plus here we have b square y square, here we have a square y square. By taking these two terms as second group, b square y square plus a square y square. By observing the first bracket, here we have a square x square plus b square x square. So, since x square is common, we can take x square as common, we got x square of a square plus b square. Next, from b square y square plus a square y square, we can take y square as common. Again we got a square plus b square or b square plus a square, both are same. A square plus b square or b square plus a square, both are same. So, x square of a square plus b square, here we have y square of a square plus b square. Again we can take a square plus b square as common. So, by taking a square plus b square as common, here we have x square, here we have y square. So, x square plus y square. So, this is the product of the given polynomial ax plus by whole square plus bx minus ay whole square. So, directly we do not have any term as common by observing the given polynomial, but we can say the first expression is in the form of a plus b whole square, the second expression is in the form of a minus b whole square. Apply these two formulae, a plus b whole square equal to a square plus 2ab plus b square, a minus b whole square equal to a square plus b square minus 2ab. So, by expanding by using these two identities, where plus 2ab xy minus 2ab xy get cancelled, by writing a square x square plus b square x square at one place, b square y square plus a square y square at one place. So, this is one group, this is second group. From the first group we can take x square as common, from the second group we can take y square as common. So, we got x square of a square plus b square plus y square of a square plus b square. Again we can take a square plus b square as common. So, by taking a square plus b square as common, we got x square plus y square. Okay. Hope you understood, ma'am. Next problem. Factorize x cube plus 2x square plus 5x plus 10. So, this is a quadrinomial, means the given polynomial contains 4 terms. So, we have to express that as the product of factors, x cube plus 2x square plus 5x plus 10. So, by taking x cube plus 2x square as one group and 5x plus 10 as second group. So, by observing the first two terms x cube plus 2x square, it is clear x square is a common factor. So, because x cube can be written as x square into x. So, by taking x square as common, by taking x square as common, where x cube can be written as x square into x. So, since we have taken x square as common, you will get x. Next, from 2x square, since we have taken x square as common, you will get 2. So, x square of x plus 2. Can you say what is the common factor for 5x plus 10? What is the common factor for 5x plus 10? Very simple. 10 can be written as 5 into 2. Already here we have 5 is there. That's why we can take 5 as common. So, by taking 5 as common, you will get 5 of x plus 2. Here we have x plus 2. Here we have x plus 2. So, that's why by taking x plus 2 as common, you will get x square plus 5. X square plus 5. So, the given expression is a quadrinomial, means that polynomial contains 4 terms. When a polynomial contains 4 terms, we know that is a quadrinomial. So, in this quadrinomial, by writing the first 2 terms x cube plus 2x square at one place, 5x plus 10 at one place. From the first 2 terms x cube plus 2x square, we can take x square as common. From the last 2 terms 5x plus 10, we can take 5 as common. So, by taking x square as common, x square of x plus 2. Here by taking 5 as common, 5 of x plus 2. So, again by taking x plus 2 as common, we got x plus 2 into x square plus 5. Next problem. Factorize x square plus xy minus 2xz minus 2yz. So, this is also a quadrinomial because this polynomial contains 4 terms. So, can anyone say how can you divide the terms as groups? Observe the given terms. What we have? X square plus xy minus 2xz minus 2yz. So, if we take first, let us write the given polynomial x square plus xy minus 2xz minus 2yz. X square plus xy minus 2xz minus 2yz. So, if we take the first 2 terms, x square plus xy. So, x square can be written as x into x. Second term is xy. So, from the first 2 terms, we can take x as common. So, by taking x as common, you will get x plus y. By taking x as common, you will get x plus y. From minus 2xz minus 2yz, we can take minus 2z as common. So, minus 2xz minus 2yz, we can take minus 2z as common. So, by taking minus 2z as common, here we have x, here we have y. So, that is x plus y. Here we have x plus y. In the second term also we have x plus y. That is why by taking this x plus y as common, we have here x minus 2z. So, x plus y into x minus 2z. So, factorize x square plus xy minus 2xz minus 2yz. I have taken the first 2 terms x square plus xy as one group, minus 2xz minus 2yz as second group. So, from x square plus xy, take x as common, we got x of x plus y. From the last 2 terms minus 2xz minus 2yz, if we take minus 2z as common, we got x plus y. Again by taking x plus y as common, we got x plus y into x minus 2z. Okay, now next, factorize a cube b minus a square b plus 5ab minus 5b. Here also in the given polynomial we have 4 terms. If you take the first 2 terms a cube b minus a square b, we can take a square as common and b as common. By taking the last 2 terms 5ab minus 5b, 5 can be taken as common and also b can be taken as common. So, here the given polynomial is a cube b minus a square b plus 5ab minus 5b. So, from a cube b a square b, we can take a square b as common. From the first 2 terms, we can take a square as common and b is also common. So, from a cube, we have taken a square as common, the remaining part is a. So, since we have taken b as common, so a into 1 a minus So, since we have taken a square b as common, that is minus 1. So, a square b into a minus 1 plus from these two terms by taking phi b as common. So, by phi b is common and b is also common factor. So, that is why by taking phi b as common you will get a minus 1. So, again by taking this a minus 1 is common. So, you will get a minus 1 into a square b plus phi b, a square b plus phi b. By observing the two terms in the second bracket, again we can take b as common. Again you can take b as common. So, that is a minus 1. Here by taking b as common, we got a square plus phi. By taking b as common from the second bracket, we got b of a square plus phi. So, a minus 1 into b into a square plus phi. So, we can express the given polynomial as the product of factors like this: a cube b minus a square b plus 5ab minus 5b. So, take the first two terms and take a square b as common. So, we got a minus 1. Take the last two terms 5ab minus 5b, take 5b as common, you will get a minus 1. Here a minus 1, here we have a minus 1. So, by taking a minus 1 as common, we got a square b plus 5b. Again from a square b plus 5b, we can take b as common. So, a minus 1 into b into a square plus 5. Okay, hope you understood more. Next, factorize x cube minus 2x square y plus 3xy square minus 6y cube. Here also let us take the first two terms, x cube minus 2x square y plus 3xy square minus 6y cube. So, from the first two terms x cube minus 2x square y, we can take x square as common. So, by taking x square as common, where x cube can be written as x square into x cube can be written as x square into x. So, that is why from x cube by taking x square as common, we have x minus. Since we have taken x square as common, the remaining part is 2y. So, x square into x minus 2y plus from 3 and 6, we can take 3 as common. Why? 6 can be written as 3 into 2 from xy square y cube. So, y square can be taken as common. So, by taking 3 into y square as common, here we have x, here we have minus 2y. So, y cube can be written as y square into y. Y cube can be written as y square into y. So, since we have taken y square as common, we can write x minus 2y. So, again by observing these two terms, clearly x minus 2y is a common factor. So, that is why by taking x minus 2y as common, by taking x minus 2y as common, here we have x square, here we have 3y square, x square plus 3y square. So, that is why we can express the given polynomial x cube minus 2x square y plus 3xy square minus 6y cube as the product of two terms as x minus 2y and x square plus 3y square. So, here we have the polynomial x cube minus 2x square y plus 3xy square minus 6y cube. So, take the first two terms x cube minus 2x square y, take the last two terms 3xy square minus 6y cube. From the first two terms, we can take x square as common. Why? Where x cube can be written as x square into x. From these two terms 3xy square minus 6y cube, we can take 3y square as common. Okay. So, by taking 3y square as common, we got x minus 2y. So, first expression is x square of x minus 2y. Second expression is 3y square of x minus 2y. So, again by taking this x minus 2y as common, we got x minus 2y into x square plus 3y square. So, that is why we can express the given polynomial. The polynomial means that is a quadrinomial because that contains 4 terms. according to the terms of the given polynomial we can name the polynomial. So, that is why this is a quadrinomial. So, we can express the given polynomial or given polynomial x cube minus 2x square y plus 3xy square minus 6y cube as the product of two polynomials like x minus 2y into x square plus 3y square. Okay. Next, factorize 3a minus 1 whole square minus 6a plus 2. So, this is simple problem. You can take the first expression 3a minus 1 whole square minus 6a plus 2. So, keep 3a minus 1 whole square as it is. From minus 6a plus 2 you can take minus 2 as common, 3a minus 1 whole square. From minus 6a plus 2 we can take minus 2 as common, you will get 3a minus 1. So, 3a minus 1 whole square minus 2 into 3a minus 1, where first term 3a minus 1 whole square can be written as 3a minus 1 into 3a minus 1. Already 3a minus 1 is there. So, that is why by taking 3a minus 1 as common, you will get 3a minus 1, here we have minus 2. So, that is 3a minus 1 into minus 1 minus 2 minus 3. So, 3a minus 3. Again from the second bracket 3a minus 3 we can take 3 as common. So, 3a minus 1 into 3 into a minus 1, or you can write 3 into 3a minus 1 into a minus 1. So, we can express the given polynomial 3 minus 1 whole square minus 6a plus 2 as the product of two or more polynomials like this, 3 into 3a minus 1 into a minus 1. So, these are some problems related to factorization by grouping. In the next class we can take another concept and we can do the related problems. So, thank you all my dear students for subscribing Turito. Thank you very much. Have a nice day.